let's try and understand this question here. So civil engineers design bridges to span over expressway. The diagram shows represents a bridge over an expressway PS. So we are told that PQ and PSR are parallel to the y-axis. So I'm just going to quickly draw this out. And that the arc of the bridge QR, yada yada, is followed by this parametric equation. So we understand that. With A is a positive constant, the unit x and y are in meters. At the point Q, theta is beta. So this is theta is beta. So these two lengths are the same height, right? QP equals to SR. So just label this. Now usually when it says parameter, I will encourage students to just write theta equals to beta at this point. And this one here, it corresponds to theta equals to 2 pi minus beta. But before we start, do you know what is parametric equation? Parametric equation is, it means that you have this parameter, okay? So, okay, let's say this is the equation that I have. This equation that we have, okay? So what we do is, let's say we sub 3 into this equation. So we sub, when P is 3, when theta is 3, we will get this point here. Okay, then after that we substitute 3.1, then you get another point. Get it? So any point that we put in, right, we just keep iterating it. We just put one point inside, then we just put one point and put it again, alright? So when we trace everything out, right, I think you cannot really see this side here. When we trace everything out, we will get the parameter, okay? But that's why the parametric equation is important, because you need to always define where you are drawing, okay? The parameter is important because it's the invisible force behind the curve. It put into the equation, it just tells what the equation should behave like. So every point would have a different parameter. Every point have a housing address. It's just like your vector line equation, which, if you remember, I believe all of you remember, your A plus lambda B, right? Your vector line equation, A plus lambda B D, right? This is a housing address. That's why this is called vector parametric line equation. The lambda is a parameter. You just put it there. That's a housing address. You specify it. So whenever you do parametric equation, it's good to just label theta is beta. Theta equals to pi minus beta, because that corresponds to the housing address. Yes. Okay, so now find in terms of distance of PS should be quite straightforward, because what we need is actually just to find the coordinate of x, right? XP here, and then the XS, and then just minus them. This one here, the distance here, we just need to minus them off, right? So XR, so let's say XP is theta. When theta goes to beta, XP equals to the x coordinate at Q is A beta minus sine beta 2 pi minus beta XR. So beta is A is 1. And then this, okay, we can simplify this. So this one here, this is beta. You can either remember that sine 2 pi minus theta is equals to negative sine theta. What? 2 pi minus theta. Negative sine theta. Okay? Or if you don't remember this, it's okay. You can just expand it. Okay, so you just expand it like using sine A minus B. This is A. Okay, this will be Distance PS. This is XR. Is it XR? Minus XS. XQ. There you go.